3.7 we've discussed about functions. Part of the reason for functions is we are going to learn about linear equations. Linear equations talk about equations that have more than one solution set. So in solving these, we will check them with graphing. So we will use 4.1 as a quick review about graphing. In 4.1, we're going to learn a lot of vocabulary words. On your study guide, you will see that those are underlined. They do not show up that same way on the forms, however. And 4.1, we're going to talk about coordinates and scatter plots. So our first goal here is reviewing some vocabulary words. We're going to talk about a coordinate plane that's formed by two real number lines that intersect at a right angle. Each point in the plane corresponds to an ordered pair. So you see our vertical axis y and our horizontal axis x. The first number in each ordered pair is going to fall on the x coordinate, and the second is going to be the y coordinate. So when we write the ordered pair that is shown on this graph, we would write it as 3, -2. Easy way to remember that is when you're reading, you always read left to right first, and then you continue either up or down on the page. So moving on to our next examples, we talk about the x and the y axes, and then we also talk about the quadrants. When we're describing where a coordinate point lands, we talk about the quadrants. Again, you can review things that you learned back in elementary. When you first learned your number line, you learned about the numbers 1, 2, 3, 4 when you first started learning how to count. So those numbers, and then also going up 1, 2, 3, 4, those numbers would be plotted here in the quadrant that is called quadrant 1. You'll notice that those are labeled with Roman numerals, and I'm perfectly fine if you just write QUAD for quadrant instead. This was the first numbers that you understood. These are both positive numbers. As you continued on, we started to teach you a little bit about integers or negative numbers. So we're going to travel counterclockwise, and the next thing you learned was quadrant 2. If you have a negative and a negative, you're in quadrant 3. And if you have a if you have a positive and a negative, you're in quadrant 4. You'll notice we do have one special point here that's shown on the graph, and that would be the point 0, -4. If I was going to describe the location of this point, 0, -4, I would say it's located on the y-axis. It is not located in any of the quadrants. It lies right on an axis. You could also have a point on an x-axis. So, for example 1, we're going to be asked to plot some points. So to plot the point 3, 4, we would go ahead and move to the right or left, and it's a positive, so we're going to move to the right, 3, and up 4. Letter B, -2, -3, you can see from the instructions. And letter C, this time we're going to move 2, but then it says 0 for our y, so we're going to say right on the x-axis. Goal 2 is talking about scatter plots. Scatter plots are important when we're dealing with real data. Many of the linear equations we'll deal with have been manipulated or used to show the example of a true linear equation. However, when we're doing scientific data and then plotting it, many times this will come out as a scatter plot. The data here about the student manager of a high school soccer team talks about the height and the weight of some patients. Now, these are just randomly picked some of the soccer teams, and so you're going to see that when I go to plot these, I will not have a perfect linear or a line graph. I have what's called a scatter plot. So when I'm looking at each one of these, I decide the x-axis I have labeled as height, and the y-axis is labeled as weight. So I use those the same way I used the other coordinate points, my x and my y. Now, by using a scatter plot, we could use that to estimate. So if we wanted to estimate the weight of a player who is 69 inches tall and one who is 71 inches tall, we could go ahead and do that by looking at the scatter plot. So the two players who are 69 inches tall weigh 150 and 160. So a good estimate would be that another player might weigh about 155 pounds if they were 69 inches long, 69 inches tall. In that same way, I could look at the player who is 71 inches. I could look at the 71 inch results, and I see I have 180 pounds. So that's the only data I have, so I could estimate they probably weigh about 180 as well. So the letter D says, what would you expect a player who is 74 inches tall to weigh? So I look at 74. I do not have any data for 74. However, the 72-inch player weighs 190. The 73-inch player weighs 180 pounds, and the 76-inch player weighs about 200 pounds. So if I looked at that data, I could estimate and say that 74-inch tall player could possibly weigh between 190 and 195 pounds. Now I got that by looking at these lines here, and then I'm looking at my 74, and I could say, oh, I also considered this point here of the 72-inch one. So a scatter plot is used for estimations. It doesn't have a perfect increased rate or decreased rate. So in example 3, they'll talk more about describing patterns from a scatter plot. So they've gone ahead and drawn a scatter plot of each set of data in the same coordinate plane. So we have snowmobiles and ski equipment. So it says describe the pattern of the amount that is spent on snowmobiles. So for letter B, the scatter plot, you can see that the amount spent on snowmobiles has been increasing rapidly since 1990. You see the blue here, and it keeps rising. Now, ski equipment, on the other hand, letter C, the pattern that I'm noticing for ski equipment is it has varied just a little bit. It seems to decrease and then increase again each year. So the amount spent has pretty much stayed at about 600 million. Sometimes a little higher, sometimes a little lower. So again, scatter plots are good to use for making estimates.